Hello, my name is Axel Scherer. I will give you a quick introduction into the UVM class library. We will have a look at the class hierarchy. And the first thing we are looking at is the UVM object. It basically has a bunch of functions built in that enable sophisticated verification, such as copying, cloning, and comparing, which are missing from base system Verilog. Also, factory methods are built into this root class and a standard way of how to print. Further on, also object identification is built into this. With this starting point, we can now start to model our traffic, right? Basically our transactions, which is essential to model our system. So the base transaction is basically the lowest level is a sequence item, as we've seen before. And the sequence item has to interact both with the sequencer and with sequences, right? And that ordered functionality, how it stacks up relative to a sequence stack, and things like this, that's all built in, ready for you to use. Now, you're building interesting stimulus by concatenating and have multiple sequence items. So the sequence class basically has a lot going on. It executes the sequence, right? So it has different tasks and methods that can be used to build up complicated sequence items. It can control the execution by locking, by priorities and things like this. It can actually execute the actual sequence items, and it has to interact with the sequencer. So a lot of tests and functions and all that stuff is built into the UVM sequence class library, ready for you to use. So that's all we need to model our traffic. Let's build up our actual verification test bench, right? That starts with a UVM component. And its main contribution in terms of functionality is the phasing mechanism, right? Building, connecting your components, winding down the whole system, that is all built into the UVM component class. We're now deriving from this class, and we have a UVM env, which is the container class for your test bench or a UVC. But it actually doesn't have any incremental functionality built in. It is just there to differentiate it from a generic UVM component. And the same is true for a bunch of other classes like test, nothing special in there, scoreboard or monitor. Again, they're just there to differentiate it so you can build your environment with a standard recommended way. Once you look at the UVM agent, however, we're adding some incremental functionality. There is a bit that has a standard name is active in there that you use to control whether your agent is driving or just observing and monitoring. The UVM driver has TLM ports built in, so it's ready to go to talk to the sequencer and to get basically sequence items to drive out into the system. So the ports are there ready for you to use. Implicitly, you can call them and use them when you code up your UVM drivers. The UVM sequencers has the other side of the ports, so these guys can interact and work together. On top of that, just by having the ports built in, it also has a lot of functionality that allows you to control basically the sequencer execution, right? So if you have arbitration schemes, you have to hold on to sequences and things like this. That's all built into the UVM sequencer class. So lots of functionality provided here. So that's basically it. You have traffic modeling in transactions, you have all the components, and you have a bunch of TLM ports that allow you to connect up different components so the traffic can flow. For example, the monitor might have to send transactions up to the scoreboard. So you just use a bunch of TLM ports. That's the class hierarchy in a nutshell. You will use only the things at the bottom in red and derive from these classes to build your environment. Have a great day. Thank you very much and talk to you soon.